So today, what we're going to talk about, all right, you don't need to write down all this stuff. I think you'll probably be able to understand this maybe without writing it down. If you'd want to write down a few examples, that'll probably make sense as well. But what we're going to do is we're going to talk about increasing, decreasing, and constant functions. And so the first one, when we think of the word increase, what does increase mean? To go up. And so if you look at this graph, as I travel from left to right, it goes up. So therefore, this would be an increasing function. And it would actually be increasing on that entire interval. Now, when you think of decreasing, decreasing means to go down. And so if I look here, this graph goes down on the entire interval. And so that graph would be decreasing. And then last but not least, what happens if it doesn't do anything but stays constant? That is what we have right here. And if you notice here in the middle, the graph is constant from there to there.
But you don't count anything from the other arrows?
Just hold on.
Slow down.
Okay, be patient. We'll get there. We will get there. So the graph is constant from those 2 points. And so now what we're going to do is we're going to identify from a graph where's the function increasing, decreasing, etc. And so if we look at this graph right here, what do we notice it's doing? It's going down. Is it going down the entire time?
Good question.
Really? It's not going down the entire time?
It is.
Are you telling me?
Don't be smart like that. Okay, and so if you look at this, okay, and we were to graph this on our own, if we go to our graph at y equals negative 2x cubed, let's look to see if it goes down the whole time. Okay. So negative 2x cubed, if you graph that specifically in the z decimal window. Okay. Now, if you wanted to see if it's constant, you can use your trace feature, and you can actually go along the graph. And as you go along the graph, does it appear to be constant? No. It doesn't appear to stay at the same y value. So as a result, it doesn't. It is not constant there. And so this graph the whole time does what? Goes down, so it decreases. So now what we're going to do is we're going to write decreasing, because that's what they want to do, and they want intervals. Since this decreases the whole time, we're going to go from negative infinity to positive infinity. These values here are always x values. That's what you're referring to. You don't use the y's. So we're saying from the left part of the graph, which is negative infinity, to the right part of the graph, which is positive infinity, that graph will be decreasing. Let's go ahead and look at this next one. G of x equals x cubed minus 3x. So from this graph, I'm going to start at the leftmost point, and I'm going to work my way left to right. So I know the leftmost point starts with negative infinity. What does it start doing from the leftmost point? It goes up. So what do we call that? Increases. So at what point does it stop increasing? 2. It stops increasing right here, right? So I go up here, and I stop increasing at this value here, which is what? 2? I think it's negative 1. Okay, it stops increasing right there, which is negative 1. Then what does it do? It decreases. So it decreases from here to, at what point does it stop decreasing? 1. So I know there it would decrease then. My x values are from negative 1 to positive 1. And then what does it do? It goes up from what to what? 1 to infinity. So I'm just going to put 1 to infinity right there. Let's look at another one. Okay, let's look at this next one. This is what shape? Parabola. Okay, so it starts at negative infinity. What does it do right away? Decreases. At what point does it stop decreasing? At right here, which is positive 2. Then what does it do? Increases. What will my interval be? 2 to infinity. Yep, very good. Okay, what about the bottom one? What do I start doing? Increase. To what point? Negative 3 is close enough, give or take a little bit. Okay, and then what do I do? It's constant from what to what? Negative 3 to positive infinity. So that's what you're going to be doing. Identify an increase and a decrease. Now that's not it today. Okay? Because now what we're going to do is, if you notice this, it says estimate and classify the extrema. Now when we think about extreme values, we have two values of extreme values. We have what is known as a max, a mum, and we have what is known as a min, a mum. Okay? A maximum is like a peak, a high point. A minimum is like a valley or a low point. So in a graph, a minimum is going to be something like that. A maximum is going to be something like this. Okay, now there are two different classifications of max and mins. They are relative and absolute. We're not going to worry about those. We are just going to classify maximums and minimums. Okay, so when you go back in your book, they will talk about relative and absolute. We're not going that far in depth. We're just going to identify max and mins. So if you look at this graph, is there a maximum value or a max? Yeah, looks like there's a maximum value like right here. That's a high point in the graph. Okay, what about a minimum? Does it look like there's one there? Yeah, right here. So now what we need to do is actually specify what x values those occur at. So my first one is a max. The x value that occurs at is about what?
Half.
Yep, about negative 0.5. There you go. That's all you have to do. What about a minimum? Where does it look like the minimum occurs? 1. Now, just a little tidbit. Not every graph will have both a max and a min. Some graphs could have more. Some graphs could have less. Let's go and look at another one. Okay, here. Do you have a max? Yep. Actually, we have 2. We have one here. And we have one up here. Where does it look like the first one occurs at? Negative 1.5. Where does it look like the second one occurs at? 1 or a little bit after. Okay. What about a min?
Oh, yeah.
Min at where? Negative 0.5, negative 0.25, something close to that. Okay, let's look at the very bottom one. What does it look like we have? 2 maxes. So let's do the max. Max at where? Negative 1, which is right here. And then where else? 0.5, 0.75? Very good. So max at negative 1 or 0.75. Then what do we have? Minimum at where? 0 and 2. So we're looking at minimums right here, 0, and right here 2. Can handle that so far? Okay, so now look at what it says, approximate to the nearest hundredth, the relative extreme or absolute extreme. So notice it said relative or absolute. I told you we're just going to find max and mins. Of f of x equals negative 4x cubed minus 8x squared plus 9x minus 4. State the x values of where they occur. So now instead of having a graph to look at, you're going to have to graph it on your own and then determine what in fact the solutions are. So we have negative 4x cubed, okay, minus 8x squared, plus 9x minus 4. Now, a good window to look at, I can tell you right now, I remember from earlier, a good window to look in was from negative 5 to 5, so I'm going to do negative 5 x min, negative 5 x max, or positive 5 x max. For y min, negative 30, y max, positive 10, and I changed the y scale to 2. Reason being, there's a lot of tick marks in there, and so that generally works a little bit better. So if you hit window and put those numbers in, okay, and go ahead and hit graph, you should see a pretty decent view of the graph. Do I have max?
Yeah.
Where?
0.5.
About 0.5? Okay. Do I have a min? Where? About negative 2, a little bit, yeah, a little bit before negative 2, about like negative 1.8, 1.9. But that's that's generally what it looks like, because the graph looks something like this. Okay, so here's your -2, here was about your 0.5. Questions? Think you can handle that? I'm going to look at another one, but I think I'm running short on the video, so I'm going to go ahead and stop and